All right, exponential models. Okay, a model that's exponential is anything where x is in the exponent. Okay, that's what makes something an exponential, is when x is in the exponent. But what we want to look at is what the bottom of that number is. So let's assume you have a problem where x is in the exponent. There are three different categories that could be in. So we're going to look at three different options. The first is called growth. Growth happens if the number that b is higher than 1. If the number that b is higher than 1, that means the thing is growing bigger and bigger and bigger every time you change the x value. Okay, so we call that a growth model. You call it a decay model if b is less than 1. Okay, then that means that it's shrinking and shrinking and shrinking every single time. So what's the only middle option? Okay, but what would the value of b?
Constant.
B would be actually equal to 1. It's the only, we have greater than 1, we have less than 1, we need equal to 1. That is called constant.
What's wrong when it's a constant?
Okay, that's when the growth doesn't change at all. It just stays the same over and over and over again. So it's like your life, right? You know, you grow your height, you're growing, growing. And then at some point you reach constant and you stay the same. And then when you get old and your bones start to shrink and the cartilage is gone, then you start to shrink just a little bit. Yes, you're gonna get shorter. Okay. All right, what do you need to know? You need to know the following formula. No, not PERT yet. It's coming. Okay, so this formula, you will get this formula, just, it is an O. It's actually a 0. It's a 0. Okay, you will get this formula on the top of your quiz, on top of your test, but I'm not going to tell you what to do with it or what the numbers stand for. That's your job. So you'll get the formula itself, but you have to put plug each number in the right spot. So let's talk about what the numbers stand for, okay? P with a little t. Sometimes some books will write P parentheses T. They're the same thing. You can do either the sub T or the little t. What that means is the population at any time other than 0. Okay, any time other than at the beginning, because the beginning would be is going to be a different one. So the population at any time other than at the beginning. It can be the past, it can be the future, it just can't be now. Because the P0 is the now population. So P0 is the population now, or starting the initial population. Okay, the population initially, which would be, or now. That's why they call it 0, because what you start with at time 0, okay, when t equals 0, that's the population now. R is the next letter. R stands for the growth rate. I put plus minus there, because sometimes the growth rate is positive, and it makes a number bigger than 1, and sometimes the growth rate is negative. Okay, so it's growth rate or decay rate. T is clearly time. Okay. K is the cycle length. A cycle length is things like once per month, or every hour, or when you hear words like per month or each hour, or it's like how often are you checking the growth? Okay, like I measure, you know, did your mom measure you on your birthday, or once per year, or whatever. Okay, it's a cycle length. How often is it happening? And so you can put in there maybe how often is the cycle happening. That's the question. So you're going to get the formula, but I'm not going to tell you what the numbers stand for, the letters stand for, and what goes where. You got to know what goes where. So let's do a couple sample problems of what goes where. All right, I'm going to give you the city San Jose.
What?
I'm going to give you the following formulas. 898, 759, 1.0064 T. Okay, that's San Jose. Tell me something you know about San Jose from that formula. Raise your hand, that would help me out. Okay, Ella.
The population is 8,000 at number.
Okay, the population now
Yeah.
is 898,759. Okay, good. Quentin.
Population is increasing
Okay, how'd you know that?
because it's a positive.
Not just that it's positive.
It's growth.
How do you know it's growth?
Because there's more.
It's bigger than 1. It's bigger than 1. Okay, the value is bigger than 1. What's the growth rate? Okay, the growth rate is 1 plus R. I want to know just what's the R. Okay, the R from the way it's written would be 0.006, oops, 0064. Okay, or in decimal, we move our decimal 2 places to the right, so 0.64% in decimal. Okay, all right, that's San Jose. Let me give you another one. I'll talk about Detroit.
Detroit?
All right, 1, 203, 368, 0.9858 T. All right, so looking at those numbers, maybe Thomas, tell me something you know about Detroit.
Its population is decreasing.
Its population is decreasing, okay. All right, good. Adam, tell me something else you know about Detroit.
Detroit?
It's what? It's got 1,203,000 people.
Okay, 1,203,368 people currently. All right, anything else we can tell about Detroit?
It's going to be minus because it's less than 1.
Okay, the rate's going to be minus. How much minus? What is the rate going to be?
1 minus R.
Okay, but I got to figure out what it is. What is the R going to be? Okay, nope, not 1.9858. Okay? Sam, put it away. All right, look at the previous growth rate. Okay, we went from 1.064 to 0.0064. How did we go from one to the other? What are you taking away? Take away 1, right? Take away 1 and it tells you what the growth rate is. So do the same thing. Take away 1.
Oh, I know.
Take away 1. What do you get? Negative
0.142.
1.
2.
Wait, where'd you get the 142 from?
No,
Oh,
that can't possibly be right. Oh, okay, I was going to say that can't possibly be right. 0, 1, 4, 2. Okay, 1 minus 0.9858. All right, so what does that mean if I change it to a decimal?
It's point
Negative
negative 1.
1.42%. Okay, all right. What's eventually going to happen to San Jose and Detroit?
San Jose is gonna increase. Detroit
San Jose is
finna
going to
decrease.
overpower
Okay.
Detroit.
So right now, which city is bigger?
Detroit.
What eventually is going to happen?
San Jose.
Okay, San Jose is going to pass it by. Okay, so we're going to use our calculators to figure out when that's going to happen. Would you take your calculator, please? And in Y1, would you put the San Jose value? And in Y2, would you put the Detroit value? So then what we want to say is, this is how you'll express your answer. Okay, when will it be as big? You can say San Jose exceeds Detroit. And I want you could just say like this, 14 to 15 years. Okay? So at 14, Detroit was still bigger, but then we made the switch, and in 15 years, then San Jose was larger. So that's fine to give me like a big 2-year span. That'll be good. Okay, so you'll work with that on your homework. Okay, a couple other things that you'll see on your homework will be problems like this. Okay, let's go to the biology lab in our minds. Okay, and I'm going to give you 100 bacteria. Okay, this is a fast-growing bacteria. This bacteria doubles each hour. Okay, it doubles each hour. All right, and I want to know when the population of bacteria will get to be 350,000 bacteria. How long will that take? Okay, when will the population get to 350,000 bacteria? So we're going to use that formula. The population T at some point in time in the future is equal to the population O for now. 1 plus R, so we know it's a positive because it's growing, and then T over K for the cycle. Okay, so this is how this is going to go. Population T at some time in the future is what number? The 350, because that is at some time in the future, not now. The P sub 0, that's for now. What do I have now? 100. Okay, it doubles, which means it's growing. And in order to make it double, it has to be 1 plus 1. That's double. Okay, double is 1 plus 1. That makes 2. That's how we get it. What if it said triple? Then what would we have? 1 plus 2. That would give me triple. That would give me 3. All right, it's 1 plus 1. All right, T over. The K cycle is that it's happening every hour. How many hours are there in a day?
24.
Okay, so it's at T over 24 for how many it's happening in a day. And now my job is to do, like we did on the homework last night, solve for T. Get T by itself. All right, what will we do to both sides to work on solving for T?
Divide by 100.
Divide by 100. So we're going to divide by 100. We'll cancel it out. We'll divide by 100. That'll give me 3,500 equals, I'm going to put 2 instead of 1 plus 1. Okay, and T over 24. All right, where is the T right now?
Up there.
In the exponent. Where do I want it?
Down there.
Okay, I want it in the front. How do I make that happen? ln. So I'm going to use an ln around 3,500. Okay, and that is going to pull the T over 24 out to the front, and I have an ln 2. How do I get this T by itself? Divide by ln 2. Good. Okay, I'll divide by ln 2. That'll reduce it out on one side. And remember, the ln's on the 3,500 side, those don't cancel each other out. Okay, they only reduce each other away on the side where they match totally. On the side where they don't, you just leave it. And then the last step to get my T by itself,
You multiply it by 24.
so I'm going to have 24 times, and somebody can start typing that into the calculator for me to tell me, please. Grab out your calculator. And at this point, we want to know how much time it's going to take for this bacteria. Does anybody have that? How fast can you type? 24 ln 3,500 over ln 2. We'll see who's fastest. 5, 5, 5. What? 5, 5, 5.
82.5.
Yes, but what are the units?
Minutes,
No.
hours.
What was the question? Units. No. The bacteria is 350,000. This is a time. This is time. Hours. The question was hours. It doubles every hour. Okay, this is hours.
I said second minutes, hours.
Okay, you can
Okay.
Okay.
All right. We go across the hall to the chemistry lab. Okay? And Mrs. Baldridge gives you 5 grams of a mystery powder.
What? Hold on. Hold on. Oh, yeah.
What?
All right, so we don't know what it is. All right, it has a half-life.
Bert.
No, not. Okay, a half-life of 20 days.
I remember this formula-ish.
Okay. Okay. How long will it take to get down to 1 gram? All right, so we're going to use the same exponential model formula. Is this a plus or a minus problem? This is minus. Half-life is when things are decaying and going down less by half every time. So this is a 1 minus problem, t over k. All right, so p of t, p sub t, some population or amount at a time not now. 1, okay? 1, that's what it will be. That's not now. It will be 1. What is it now? 5. Okay, 1 minus. What is the decay rate this time? It has half, or 50%. Okay, t over, and what is the cycle length? This is happening every 20 days. All right, so as long as you get all the numbers in the right parts, you'll be able to solve to get that t by itself. So 1 minus 0.5 is half. Okay, this is a half-life, which is why I'm using half for my number. All right, what's my first step?
Divide by 5.
Okay, so we have 1/5 equals 1/2 to the t over 20, and thankfully we know what to do with these problems. Okay, we don't want 1/2 and 1/5. We want 5 to the negative 1, and we want 2 to the negative 1. Okay, because that's why we did our homework before, so we would learn what to do with those numbers. Then we can use our ln to help me pull my powers to the front. So we're going to use our ln to pull the negative 1 to the front, and we'll use our ln to pull our powers to the front. So that gives me negative 1 in front of ln 5. It gives me negative 1 and t over 20 in front of ln 2. Okay, so I'm pulling my powers to the front. Okay, both the powers.
So does the negative 1 on that one side always have to be in front of all the rest?
Okay, so what would you like to get rid of first? The negative 1? Sure, there's a negative 1 on both sides, so I can cancel that out. That's fine by me. We'll get rid of it. Okay, all right, what do you want to get rid of next?
Divide ln2.
Divide by ln2, okay. So we'll divide by ln2. Remember, those only the ln2s cancel out, but not the ln5. And I do want to point out what I have not used this whole time yet. Okay, please wait until the end. Hold off till the end. Last step, multiply by 20. So 20 ln5 over ln2. And now you can use your calculator to figure out how many days, excuse me, this is doubling every hour, right? 20 hours? No, 20 days. How many days this will take to happen? Who's got it?
46.439.
Oh, wow.
Kind of a point for
And this is days. Okay, we have one more question. So we've been in the biology lab. We've been in the chemistry lab. History. Okay, I think we're going to go to Mrs. Brass' psychology class. Okay.
Oh, I got gypped.
All right.
RT?
R sub t. Okay. We are no longer talking about a population, we're talking about a rumor. Okay? Because you know how populations can grow, so can rumors. And how fast do rumors grow?
In Valley fast.
Okay, fast rumors. So we're going to talk about how fast a rumor grows this time. Okay? So, what I'm not going to tell you, you will have to figure out how many people know the rumor now.
Probably everyone.
Okay? So when I say now, what time are you assuming?
That's your bet.
Okay?
Constant 0.
When I say now, how much time has passed?
Nothing.
None. Okay? So how many students know how many students know it now? Okay? No, that is not true. You can't start a rumor with no students. Nope.
0.
2.
How many students know it at time 0? Well, you're going to have to put time 0 into the problem and figure out how many students knew the rumor at the beginning. So we're going to take 1200 over 1 plus 49, e to the negative 0.9, and we're going to drop 0 in for time. We're going to figure out how many students actually knew the rumor. Well, what does the 0 do to the 0.9? Makes it a 0, right? Everything times 0. So now it's e to the 0. What is e to the 0?
1.
Okay. So now I have 1200 over 1 plus 49. What's 1 plus 49?
50.
Okay. What is 1200 divided by 50? Who's got it? 1200 divided by 50.
24.
24.
Okay. That's how many students knew the rumor at the beginning. It's the whole class. Something happened in Mr. Brass's psychology class, and all 24 students know about it, and they all leave and go out to lunch, and they go, oh, did you hear what happened in Mr. Brass's 4th period psychology class? And boom, those 24 students spread the rumor. Okay, and then it's going to start spreading. Now, what happens to rumors is that they spread really fast at the beginning, but they eventually die out. So this is what rumors look like. They have a spike, but eventually the rumors die out and level off, and people become bored with the rumor, or it's disproved, or everybody knows, and then it's done. Okay, the rumor will always die off at the numerator number. What's the numerator number? 1200. So 1200 is where it's going to die off at. That's always true. So it starts with 24, and then it's going to have a spike where everybody's talking about it, and then the rumor will eventually die off. The same thing happens with a disease as it spreads. It starts off with a certain population, spikes, and then levels off as the disease spreads.
Thank you.
All right. Have a good rest of your day.